Hello everyone, today we are having our second lesson for designing solid slab, one-way solid slab. In the last lesson, the last point was calculating the moments, and we are done with calculating the moments, and we got this last shape which describing the moments for the supports and for the spans. Today from these values we will start designing and getting the reinforcement that needed for each support and span. Starting with the design step, which is the sixth step, design. So okay, we will divide the designing into sections. So first of all, we will design the spans. I will design the spans in the short direction, then I will design the supports in the short directions, and after that we will design in the long direction. So let's start with the first one, which is span short direction. Short direction. And we will start with S100, S101 and S103 because they are the same. So let's start with and the moment value we have for these two, M equals 10.31. This is the most important point, almost kilonewton times meter. So we will have okay, first of all we will have the first check. We do it in according to multiple checks. We have 3 checks in the designing section. So let's go. Okay, now we will start minute 2. Okay, we have the moment value, then we will go to the design section. How we design. This is the designing formulas. First of all, as you see here, the span and support short direction, the formula for designing span and support. After we design all the span and supports, we will start with the long direction for the support and for the temperature steel in the long direction. So first of all, we have 3 checks in the designing for span and support, and we have some formulas to define the area of steel. Then we will check the space, and then we will define the real area of steel. So just like normal steps to solve to find the area of the design of the span and support. So we will start with the first step, which is check 1. Check 1. We will calculate the K value. K value equals BW times D square divided by MD. So BW equals 1000. D was equal to 110 square in millimeter divided by 10.31. Okay, 10.31 in the MD is in kilonewton times meter. We will convert the meter to millimeter, so it will be times 1000. 110 square divided by 10.31, and the value, the final answer equals K equals 1173.62. Okay, this value will be compared with another value called KL. And in this question, KL might be given as 150 or something like this. It should be given. Otherwise, there is a table for this value. So this check passed. After that, we will calculate the area of steel. Area of steel equals to MD divided by JD times FYD. Okay, we have FYD, it equals to 365 because of S420. We have a table for this one. Okay, we can check the table. Also, like depending on the code you are using, but however we are using this code. So FYD is equal S420, and according to all concrete types, it's the same value. So it will be 365. This is the FYD value. Okay, so 365, and JD let's calculate JD on the side. JD in general equals to 0.86 times D. So 0.86 times 110, and it equals to 94.6. Okay, after that, let's calculate the moment. The moment equals, okay, first of all, the moment 10.31, we will convert it into kilonewton times millimeter, because 1000 times 1000 two times, divided by JD was 94.6 times the 365. Why? Because 365 here, it's in megapascal, which is in Newton, divided by millimeter square. And this kilonewton, the moment is kilonewton times meter. So converting the kilonewton to Newton times 1000, and converting the meter to millimeter times 1000. So 10.31 times 1000 two times, divided by 94.6 times 365, and it equals to 298.6. Area of steel equals 298.6 millimeter square. This is, we calculated the area of steel. After that, we will calculate the space. Okay, the space equals to B divided by area of steel times area of the bar. Okay, area of the bar, we assume that the bar size is 10. So we'll calculate according to this value. So B, it's 1000, or BW, and area of steel was 298.6, and the space was, while the phi is 10, pi times 5 square, and it equals to, the space will equal to 1000 divided by 298.6 times pi times 5 square, and it equals to 263 millimeter, almost. This is the space. Okay, after that we will check the space. So check space. So we have two conditions to follow. First one, it should be, the space should be less than 1.5 HF, and the second one, the space should be less than 200. So 200 millimeter, 1.5 HF was equals to 130. So 1.5 times 130, it equals to 195 millimeter. Okay, in all cases, S is smaller than these two values, like 200 and 195. S is smaller than them, so we will use, S is bigger than them. Yes, S is bigger than them, so we will use, in that case, we will use the smallest one, which is 195. So we'll use the space 195 millimeter. Out of these three, you use the smallest one. So we will use the 195. Then we will calculate the real area of steel, because the space has changed. So real area of steel, AS equals BW divided by S times the area of the bar, and it equals BW 1000 divided by 195 times pi times 5 square. So 1000 divided by 195 times pi times 5 square, and it equals to 420. This is the area of steel. We will use 0.77 millimeter square. Okay, now we will have the last check, which is check for reinforcement. Check for reinforcement ratio. Check ratio. Okay, the ratio equals to AS divided by BW times D. So area of steel equals 402.77 divided by 1000 times 110. So 1000 times 110, and the ratio equals to, ratio equals to 0.00366. This value The condition is to be bigger than the minimum and the smaller than the maximum. Some codes or some courses they use formulas, but I will use the tables. So the S I have in this question is 420, and the C I have is 25. No, sorry, this is a different table. Yeah, this table. So I have S 420 and I have C 25. According to this table, the ratio maximum should be 0.0178 and ratio minimum should be 0.0025. So in this case, the value I have is bigger than ratio minimum and smaller than ratio maximum. So, okay, it should be like this. Okay, we are done. So finally we will take the space that we used and the bar we used. So phi 10 divided by 195. This is the final answer. This is the final answer. But also we have another step here, which is this value will be divided into two sections. This one will be phi 10 divided by double this value, because 195 times 2 it equals to 390, and also phi 10 times 2, which is 390, which is bent up bars and straight bars. What does it mean? When we design in the design section, when we draw the steel bars or when we put the steel bars, this one steel bar we put it as straight and one steel bar we put it as bent up. This okay, this is phi 10. Okay, another thing, yeah, after putting the straight bar and then a bent up bar, we put again a straight bar. Okay, the space between this steel bar and this steel bar is 195, because the main steel bar we have is the space between each one, and the other one is 195. But then we have from this straight bar to this, from this bent up bar to this straight bar, we have another 195. So the real space between this straight and this straight is 390. This is the meaning of it. And why we do that? Because the bent up bars are helping the supports. So they are helping us to decrease the number of the support steel bars that we will use. So half of this steel bars will be used as span steel bars and support steel bars at the same time. Okay, now we are done with this span 100, 101 and 103. We are done with it. Then we will go to span. Now span 100, 102. So the area of steel equals or the moment equals 8.48. Moment equals 8.48 kilonewton times meter. So first of all we will calculate the K. K will be bigger than KL directly. I'm not going to calculate it because logically the difference was so big here, because the difference was so big here. So this one it will be less or more, but not a big difference. So in all cases it will be more than the KL. Then we will calculate the area of steel. Area of steel equals to the moment, which is 8.48. We will convert it into Newton times millimeters. So 1000 divided by the JD, which was 94.6. We calculated it here. 94.6 times the FYD 365 from the table. So 8.48 times 1002 times divided by 94.6 times 365, and equals to 245.591 millimeter square. And then we will calculate the space. The space equals to the B divided by area of steel 91 times the area of the bar, which is pi times 5 square. I'll use the same bar, which is 10 for the spans. Okay, 1000 divided by the answer of the area of steel times pi times 5 square, and it equals to 319.8, which is now check for space. This is the first check, and here we will do the second check. Check 2 for the space. In both cases, S is less than HF 1.5 HF, and S 200. So S is bigger than both conditions. So we will use the same span, the same space, which is 195 millimeter. Okay, in this case we will use the same area of steel, because when we calculate the real area of steel, we have the real area of steel equals to BW divided by S times area of the bar. When we calculate it, we will get the same value, because we use the same space. So we will use the 402.77 millimeter square. In this case, you might reduce the ratio, diameter of the bars you are using. Instead of 10, you can use 8, but I will keep it as 10. It would be better, more safe, because also we are talking about the main reinforcement, so I will keep 10. And after that, we will calculate the ratio. No need to check the ratio, because ratio will be bigger than ratio minimum, because it's similar to the previous one, and it will be smaller than ratio maximum. And we are done with it. Also, we have phi 10 divided by 195, and half of them will be phi 10 195 phi 10 sorry phi 10 divided by 390, and phi 10 divided by 390 for bent up and for straight. Okay, then we will start the support. So first of all, we have support x1 and x4. We will calculate x1 and x4, which is 4.73 and 4.73. So the moment is 4.73 for both of them, kilonewton times meter. So K will be bigger than KL in all cases. It won't be less. And then we will calculate the area of steel. Area of steel in this case will equal to, so 4.73 times 1002 times, because we will convert it from kilonewton to newton and meter to millimeter, same steps. And then we will calculate the JD is 94.7 times the FYD 365. So the area of steel equals 136.84 millimeter square. Okay, after calculating the area of steel, here there is one point to do in this point. Okay, the real area of steel will be different than this area of steel. Why? If you remember, here I told you that this bent up bars is supporting the support. So instead of adding instead of using all this area for the supports, we will decrease it from the bent up bars, because these bent up bars are working as supports. So the bent up bars are half of the area that we are using here, so which is half of 402. What we will do here, so real area of steel will equal to the area of steel that we have, 136.84, minus half of the area of steel that we have, which is 402.77. Half of this value is working as supports from the span, 402.77 divided by 2. So this will be 136.84 minus 402.77 divided by 2, which is equals to minus 64.5 real area of steel. So in this case, while the value is in negative, so no need for support bars, for supports. Okay, if the value was positive, then we will calculate the area of steel according to the space and everything. But while the value is negative, so no need for supports. We are not going to add the supports in this case. We already have from the bent up bars, the steel bars we have from the bent up bars are sufficient and enough. So this is for x1 and x4. Let's calculate support x2 and x3. x2 and x3. So here the moment we have was 11.71. So the moment is equals 11.71 kilonewton times meter. First of all, the first check K will be bigger than KL, and then we will calculate the area of steel. So we have the moment 11.71 times 1000 square, or 2 times, divided by JD, which is 94.7, times the FYD 365, which is equal to 338.78 millimeter square. Okay, now we have, okay, we will check again the real area of steel. But this case is different. Why? Because these supports we are working for are stuck in the middle here. So this support and this support, they are in the middle. So it means that the bent up bars from this part are supporting this, and the bent up bars from here are supporting this also as well. So we have support from the right side and from the left side. Both of them are supporting this. So here the area of steel, which is 402, will be supporting half of it will be supporting the support. The 402 from this one will be supporting the support, and also here the 402 again from this the other span will be supporting this support. So we have half of 402 and half 402 two times. So it means 338.78 minus half the 402.77, half of it and half of it again. 402.77 divided by 2.77 divided by 2. So it means 402.77 divided by 2 minus 402.77 divided by 2 again, 2 times, and it equals to minus 64. And also it equals to minus 64. So again, no need for supports here. Okay, we are done with this point. After that we will calculate the support for the long direction. Let's now we will calculate the support for long direction. Long direction. So support for long direction, we will use the formula AS equals 0.6 times the area of steel for the span. Remember this point, the area of steel for the span, not for the support. So area of steel for span, okay, 0.6 times. So the support for long direction, we will calculate it for all the slabs, but while we have the same area of steel for all the spans, we have the same area of steel, so we'll calculate it we are going to calculate once, and we will apply it to all of the supports. So the value we have 402.77. So the formula 0.6 times 402.77, and it equals to the area of steel, then equals to 241.66 millimeters square. To calculate the space between the steel bars, we will use the same formula, B divided by area of steel times area of the bar, and also I will use phi 8. So it equals B 1000 divided by the area of steel times pi times 4 square, and it equals to 207.99, 208 almost. So I will use the space for 205 millimeter. No need to change it. So 205, so it will be, the final answer will be phi 8 divided by 205 5 millimeter. This is the final answer for this one. This is the support steel, and then we will calculate the temperature steel. Temperature steel. Why we are calculating this? Because in the long direction we need some support steel and some temperature steel. We cannot neglect this because it's important to put this steel in the other direction. We cannot leave it without any steel bars. That's why we are calculating them. So here the formula is area of steel equals 0.5 area of steel divided by 5. The area of steel for the span again. So which is 402.77 divided by 5, and it equals to area of steel then equals to 402.77 divided by 5 and equals to 80.55 millimeter square. So I would use, actually the area of steel is so small, so I would use phi 6 because the area of steel is so small. So 1000 divided by the area of steel times pi times 3 square, which is 350.99 okay, space 351 millimeter. So here the space shouldn't be bigger than 300. Max equals 300 millimeter. Here the maximum is 300 millimeter. It shouldn't be more than 300 millimeter. So then I will use S 300 millimeter. So the end is phi 6 divided by 300 millimeter. And here we are done. Okay, the last point I will draw. So here I will add the draw. Okay, so we have these 3 slabs. First of all, we will draw for the span supports. So I have it will be like this. As you see, this is the straight up bars and this is the bent up bars. It will be like this. The bent up bars will help the supports, and also here it will be the same. This is the straight and this is the bent up bars. It will be like this. And here again we have the straight and the bent up bars are going to be like this. So yeah, these are the first bent up bars and straight up bars, which is phi 10 divided by 390. So phi 10 divided by 390 for all of them. Phi 10 divided by 390. Phi 10 divided by 390 and phi 10 divided by 390. Phi 10 390 and phi 10 divided by 390. Okay, we are done with this. And then we will, okay, for the supports, no need. So we will go for the long direction. We have phi 10 divided by 205. This is for this one, supports in this direction. So we will draw it like this. Okay, let's change the color. Okay, let's draw it in the blue color. So it will be like this. It will be like this, and it will be from both sides. So all of them are phi 8 divided by 205, and for all phi 8. It would be better to write it for each one, better than writing it just one time and adding the value. No, it's better to explain it for each one. Phi 8 divided by 205, because it might differ sometimes. Phi 8 divided by 205 and phi 8 divided by 205. The last one we have it here, which is the temperature steel, which is phi 6 divided by 300 divided by 300. Okay, this one will be here in the long direction, phi 6 divided by 300, and we will have it also here, and we will have it here, phi 6 divided by 300 and phi 6 divided by 300. And this is exactly the needed draw, or the last draw you need to draw it. And yeah, that's the end of this example. If you have any questions, just let me know, and good luck to you all, and see you in the next session. Good luck.